and welcome to PEEPanEIP Focus Series, where we discuss an Ethereum improvement proposal and understand how it is going to help Ethereum ecosystem. I'm your host, Pooja Ranjan, and with me are Brent Alsop, Alita Moore from Ethereum Cat Herders. Before we proceed, a quick reminder, if you have missed any proposal that we discussed in earlier episodes, you may follow the recording available on PEEPanEIP playlist at Ethereum Cat Herders. Today, we are going to have an overview of EIP-2876 deposit contract and address standard. This is a standard track ERC created in August 2020, and at present, it is in the draft status. We are joined by the author of the proposal, Jonathan Underwood. Welcome to the show. Let us know a little bit about you and how you got involved in the blockchain space. Then we'll go over with the overview of the proposal, and we will have a few questions for you. So without further delay, let me pass it on to the author.
Thank you so much, Pooja. I'm very honored to be on this show. I've seen some of your other episodes and definitely like what you guys are doing here. How I got into the space. So I've been in the cryptocurrency space since, to give you an idea, the first altcoin, the first coin after Bitcoin was Namecoin. And I got into the space a little bit after Namecoin came in. And so probably about 2012. So this was back when Vitalik was still, a big Bitcoiner, and he was writing articles about Bitcoin and whatnot. So I've definitely been here a while. And yeah, so just to give you a background of what I've been doing in a professional sense, I started working professionally, like as a daytime job, on Bitcoin and related cryptocurrencies since I would say about 2014 or 15, a little bit after Mt. Gox happened. And I've been mostly working on open source projects. So I'm the lead maintainer of EIP-2876, which is a library for manipulating, Bitcoin and related currencies such as Litecoin and Dogecoin in JavaScript. So we are one of the largest libraries for cryptocurrency on NPM, the JavaScript ecosystem. And so working at an exchange, one thing that I see daily is the different methods in which we manage customer funds. And during that job that I had, I could say without a doubt that the most difficulty that I had was Ethereum. And right now we don't support any ERC-20 tokens. We only support the native Ethereum coin. And even just with that alone, without having to deal with all the different ERC-20s, it was taking up the most time from all of our developers, and not only developers, but people who manage the cold wallet keys and whatnot. And so when I was looking through the different ways that we could solve our problems and reduce the kind of the strain put on us, I looked into it a lot deeper and saw that there was a lot of inefficiencies in the network. And so I made this proposal because I thought it would be a win-win-win situation. The network would win, we would win, our users would win. So I basically made this proposal. The main part is the kind of the address standard. So it's basically just saying, we want to have some sort of identifier so that we can use one account for multiple users. And then the deposit contract is just a standardized way of dealing with that. So it's EIP-2876. And it's the deposit contract and address standard. So starting with the topics, we'll just go ahead and start with some motivation. So The motivation for this EIP was basically because there was no memo/destination tag feature. In other account-based cryptocurrencies, such as Stellar, Ripple, and whatnot, they all have some sort of feature where you can put kind of any string or any sort of extra data that you want onto a transaction. And the way that most exchanges use this is they will give each user a specific nonce or a specific random data that is linked to that user of the exchange. And so when they send us Ripple or they send us Stellar coins, in that transaction, if they have the memo and the destination tag that is attributed to their user, then we know when we see that transaction, we can look at the memo area or the destination tag area, and we can say, okay, this deposit was for this user. Whereas all of our users are sending the coin to a specific account. So the way that kind of increases efficiency is that if we had to have a separate account for each user, it wouldn't be that difficult from a key generation standpoint because of all the HD key libraries and whatnot. It makes it very simple. But the problem is that we need to, for accounting purposes, move all of those funds into one kind of area so that we have them protected under like a cold wallet. So in Ethereum, because there's a lack of that feature, we need to have an account per user system. And since the accounts can be EOA accounts, so accounts that are just basically the hash of a public key of a private key that someone has, like maybe from their ledger device or whatever, and contract accounts. So if you deploy a contract on the network, it has an account, it has an address. So with these two different types of accounts that we have that we can give to each user, there's basically three methods of doing a deposit system. The first two are using EOA accounts. One of them is a hot wallet forwarder that is automated. So when someone deposits to their address, we have an automated hot wallet system that will automatically send all those funds to our cold wallet. The second one is an EOA account where it's a manual cold wallet, where basically every time someone deposits, obviously we can't do it real time because our cold wallet signers are higher ups in our company and they don't have all the time to be sitting there signing transactions all day. So we basically just say, okay, you've deposited to a cold address, so we don't need to move it immediately. So whenever we need to kind of refill our hot wallet for sending out withdrawals, maybe we'll have some of our cold wallet signers come in and sign a couple thousand accounts and empty them out. So because in Ethereum there's only one, you can only have one from address per transaction. We'll just basically generate a couple hundred or a couple thousand unsigned transactions and feed them into our offline signing application, which will then run through all of those and sign all of those. And then basically we have these kind of spikes of tons of transactions that we just flood onto the network, which is hundreds and sometimes thousands, which kind of plugs up the blockchain quite a bit, since one block only has a couple tens or maybe 100 or 200 transactions. And then the last one is each deposit account is a contract. This is a huge onboarding cost because we want to create an account, a deposit account for the user, regardless of whether they have any plan to deposit. So we need to have a deposit address to show to them. So that's kind of a high cost. I mean, there's a lot of different proposals for how you can deterministically create the address using a create to deployment method. But those are kind of difficult to manage. And also they have the disadvantage of if you are trying to use some sort of event emitter that will kind of tell you about the deposit, then you need to have the contract actually deployed before the user can actually deposit. So it's a very difficult problem. So this is actually quite a huge waste of gas. If you actually work it out, I think it's on the last slide, yeah. So the automated hot wallet forwarder, assuming that it's just a pure value transaction, the user sends a transaction to our hot wallet, deposits, and then we send another transaction to our cold wallet. So basically, we're essentially doubling the amount of gas needed in order for one user to deposit onto an exchange. So this is extremely inefficient, and for ERC20, it's even worse because ERC20 transfers are usually about 52K or 53K, depending on how much balance is left after the send. So it's a huge waste of gas from a network perspective. So for instance, if we did have a tag or a memo system in Ethereum, then you could send Ether, the native token, or ERC20 or any NFTs or anything you want. And then you would just add a tag to the transaction. And basically what you'd be saying is this transaction was initiated on behalf of or by the user that has the tag, XYZ. And then that way, when we see a transaction for a deposit to our single cold wallet account, then we could then look at the inside of that transaction, which is signed, and we know that whoever signed this valid transaction wants whatever value that was deposited from this transaction to go to this account on our exchange. So that then only creates one transaction on the blockchain, and it saves a lot of gas. It saves us a lot of money. It saves our users a lot of money. And if you look at the on Etherscan, they have the gas guzzlers ranking. Obviously, Uniswap and DeFi contracts are way up there right now. But if you look at and you remove the DeFi contracts, a large amount of gas is being spent by Tether and these other ERC20 tokens. So if we can reduce the amount of gas that those guys are spending, even just a reduction of a couple of % of the overall gas usage on the network will definitely help with the fee problems that have been occurring recently. So waste of gas is bad for the network, bad for us, bad for our users. So in order to kind of help that, I created this.
Actually, mind if I just hop in and clarify one thing really quick? So just to clarify a bit, like, are you saying that what you're implementing is, so like, for example, if you're given, if you're like a package person, right? And like, so someone gives you like a package, and there's no like note on it, like you have to open the package in order to figure out who it's for or whatever, or like to show that it's like legitimate, I guess, or something along those lines, like, and then the person delivering would have to open it and then repackage it, right? Whereas you're saying that you would just put like a label on top that would sort of provide that information automatically. Is that what you're saying, or am I misunderstanding?
Well, yeah. So the way I like to kind of make an analogy for, addresses, like physical addresses, is it would be like if our postal system did not allow packages that say care by or like care of, whatever. So a lot of times when you send a package to a company, you're not sending it to the company, you're sending it to a specific employee of that company. So you say, whatever co, and then you say like CO dot the name of the employee. And then that way, when they get the package to the company, they go, oh, we'll give it to Bob. Whereas in Ethereum, you're not allowed to write care by. Like you're only allowed to send to a building. You're not allowed to send to a person, you can only send to a building. And so if everyone sent their money to our building, we don't know which employee is supposed to get this package. So what we need to do is we need to create a bunch of new buildings. And so in order for every user, we create a new building. And let's say creating a building is like deploying a deposit contract for that user. Then it costs a lot of money because we have to create a lot of buildings, even for users who will never send us a package. And so once we get a package to that building, we have the the person in that building basically relabel it to our company. And then after they send it to us, they say, oh, by the way, this package is for XYZ, like using the phone or something, because we can't paste it on the whatever. So the way we differentiate between which user is depositing is by, creating a new building for them to send the package to. And we know which user is depositing by the fact of which of these buildings that we created they sent to. Whereas if we could just write on the label, like this is for Bob, then everyone could just send it to our main office, and we could just look at the label and say, oh, this is for Bob. And we could just give it to Bob, and we won't have to like send two, postal, packages and whatnot.
So
That's
is the
analogy
building
I go with.
itself the expensive part, or just the repeat transactions?
So it's twofold. So building the building, obviously, it creates a lot of CO2. It costs us a lot of money. It's really expensive, but also it's a lot less efficient for the planes and trucks or whatever that take the package to that building that we created just for accepting packages, and then they have to do it all over again, set it on a plane and put it on a truck and whatever to our office. So there's also the inefficiencies of the actual sending of the package. So when you send a transaction in Ethereum, the base is 21K gas. And the more gas that is used on the network, the more congested it gets and the higher the fees are. So if we can get rid of all of that excess travel by going through all these different buildings or whatnot, and it just went directly to our office and we could read just a little label on it, then that would lower the gas costs quite significantly.
Okay, thank you very much. I think we can move on.
Okay, thank you. So in order to kind of add a tag or memo system, that would be a hard fork. So this is kind of a huge hurdle, especially since there's already a lot of different proposals for hard fork stuff on the table of everyone. And to be quite honest, from what I've gathered by kind of trying to get into the Ethereum community, is no one really cares about the efficiency of deposit systems on centralized exchanges, even though it's a huge waste of gas and it uses up a lot of gas on the system. Basically, everyone's more concerned with other different problems. So I kind of felt like, well, in that case, someone from a centralized exchange kind of needs to be the champion for this issue. And one of the best ways to become a champion for an issue in any space is to kind of start moving towards a standard. So I started off with this EIP. This is an abstract I pulled directly from the EIP. And the reason why I set it up this way was because this does not require any forks of the network, and it can be done by any exchange as long as they follow this system. And if we can get all of the wallets, so like all of the different exchanges that are sending out transactions and all of the user wallets like Ledger and MetaMask and whatnot, if we can get them to support the addresses and to support sending to this type of interface, then we can lower the gas costs quite significantly by using a single contract per exchange, where basically you're sending the package, the ether or whatnot, to their contract, and then you're basically adding the extra data, so that kind of tag or memo as a basically as a parameter to one of the methods on the contract. So the way that this differs from those different methods that I said earlier is that we're using a contract, but this contract is not per user. It is one contract per exchange. And then we basically create the different IDs or whatnot. And then the contract itself is what is used to kind of manage the tag data. So rather than managing it natively in the blockchain of Ethereum, we're managing it using a specific smart contract that is standardized in this EIP. So basically, a compatible deposit system can accept Ethereum payments from multiple depositors without the need of managing multiple keys or requiring use of a hot wallet. The wallet application can send Ethereum to a compatible deposit system in a way that the deposit system can differentiate the payments using an 8-byte ID specified in the standard. And then basically, if we adopt this with all exchanges, it will lower cost because 2 value transactions, one to a hot wallet and then one to their cold wallet, is 14,000 gas. Whereas I have created a proof of concept deposit contract, and during the deposits on that, it's more close to about 30,000 gas overall to deposit into that contract. So it lowers the cost of gas by quite a bit. It would be a lot lower if there was a memo, tag system that would go down to half, which is 21,000. But it's better than nothing, and it doesn't require a hard fork. So this is the actual specification of what exactly the EIP is saying. So first and foremost, the most important part is a 8-byte ID. So we're kind of defining what this ID is. And basically, the ID is an 8-byte piece of data. And it consists of 2 parts, which is a 5-byte nonce. Nonce meaning like just a random value or whatever value you wanted to give each user or whatnot. And then a 3-byte checksum. So basically, you take the base address. So if I wanted to send to this centralized contract that each exchange has one of, the base address will be the address of that contract. And then the nonce is just a 5-byte random value that is given to each user. So each user has a unique nonce. So in that case, you would generate the new address format by following this JavaScript function right here. If you don't read JavaScript, basically, TLDR version is you take the base address and the first 5 bytes, which is the nonce here, and you stick them together, removing the OX at the beginning of the nonce. And you hash them using KESAC-256. And then you take the first 3 bytes of the KESAC-256 of the nonce and the address together, and then you stick that on the end. So that way, if we are verifying it, which in the EIP, I show a way that you can actually verify it in Solidity. So in the contract itself, if you want, you can actually look at the 8-byte ID, and then you can verify that the checksum actually matches within the contract. So you could reject the payment if the checksum doesn't match. The way that you do that is you would take the 8-byte ID as a parameter, and then you would take the address of this contract that you're actually using right now, and you're sticking the 5 bytes on the leftmost 5 bytes of the ID together, and then you're taking the KESAC-256 hash. Then you're getting the leftmost 3 bytes of that hash. And then the kind of bytes 8 uint64 part is just a clever way to take those 8 bytes that you put in the ID and shift it over 5 bytes so that the last 3 bytes become the first 3 bytes. And then basically we're taking that 3 bytes, putting it here, and we're checking that these two are equal. And if they're equal, then it's a correct checksum. So using this checksum will help a lot because one issue that we do have that I didn't put in the EIP because it's not really that relevant to Ethereum is that a lot of users, they incorrectly input their destination tag / memos for Stellar and Ripple. And that causes them to deposit to other users' accounts or XYZ. So by adding this checksum system into the ID system itself, we can make it so that if they do a Butterfingers and they accidentally mistype it, although I don't know why you would manually type an address nowadays, then we can actually catch that before they actually make the deposit. So this is the main part is here's how we define the ID, here's how we define the checksum in the ID, and this is how we define the address system that includes the ID so that we don't accidentally send money to the contract without the ID. And then basically the contract itself is just a very simple interface, which is just a deposit bytes 8 ID. It returns a bool. In the EIP itself, there are a lot of stipulations using must, should, and whatnot, where a deposit contract creator must do XYZ. I won't go into the many details of that, but basically the implementation of this is an address format and then a contract interface. And basically you use this contract interface to send the money, the Ether tokens, to the centralized contract of the exchange. And then you use this method to pass the 8 bytes at the end of the new address format. And then that way we can know by looking at this ID who it is that we're actually depositing the money for.
So, okay, if you don't mind me hopping in here,
Sure.
There's a HTTP, which is like internet method. By the way, I'm just saying that like because I'm trying to be. But anyway, so like, and at the end of the get method, right, you have optional parameters, right? And so is this similar to that in the sense that you're basically just tacking on a couple optional parameters, which are the user ID on the end of the address?
Exactly. Yeah. So in Ethereum, when you send a transaction, there's a value transaction which doesn't have any extra data, and that's the kind of the package that's not allowed to write anything except the address. And then there are transactions that actually call methods of contracts, which is basically you know, I don't know exactly how to make the analogy to the address thing, but basically you're calling a contract similar to the way you would call a DeFi contract and say, I want to swap this coin for that coin, please do it as I instructed. You're basically doing the same thing, except instead what you're doing is you're calling to our centralized contract and you're saying, I want to deposit this Ethereum to this ID. And then our contract would then take that ID and we would check the checksum and make sure that it's a valid ID. And then once we've done that, then we can say, okay, I'm going to tell my internal exchange deposit system by emitting an event or something and say, okay, this deposit of X Ether is for this user. So basically, it's like what you said, where if you add some sort of like parameters at the end, you're telling Google, oh, when you open up this page, I also want you to sort it by XYZ. And so you might have something like question mark, sort equals item name. And then when you open up the page, you don't need to click any buttons. It's just sorted by item name as soon as you open the page, because when you made that GET request to the Google server, they'll be like, oh, okay, he wants us to return the data with it sorted in this way. So it's similar to that, except instead of using a server to query to, you're querying to a contract that is on the network. So yeah, your analogy is very good.
And so in this case, would that be obfuscating? Sorry, would that be avoiding like the necessity of like a building, or would that be, or would you still require that because like the transaction address, right? Okay, so if I'm understanding it properly, the transaction address would include the user ID, right? And so in that case, how does that work though? Because like, are you setting up a like a custom address?
Yes. So in the analogy we did before, each user gets a contract. So each user has a building. So in this EIP, which the reason why we're doing this is because it doesn't require a hard fork. We're creating a separate building, but it's only one building per company. So each company will have their main building, and then they'll have a EIP-2876 building. And then that's it. So they don't need to make one building per user. They just need to make one extra building. So every company will have 2 buildings. And then that one building will basically say, okay, when you send a package to us, you are allowed to add this extra data in a specific format, and we will accept it. Whereas other buildings in the world won't accept that. This special building, because it's a smart contract and it's allowed to make any rules and stipulations on extra data that is included in the package, it can make any stipulations it wants. Basically, we're defining that the contract will say, we are allowing you to add an extra data with the title deposit and the contents of a 8-byte ID. And then we will send you a reply we're not really sending it. So, but we're basically saying, when you send us the data, we will, make a reply that is a bool. So we'll say, okay, this is good or this is bad. We'll say true, false. This is good, this is bad. And then, so when they send a package to us, it will have that extra data, which will let us know which user this deposit is on behalf of. And then also we'll be able to tell the guy who actually delivered the package to us, would be like, okay, this looks good, or no, this is bad. So that's basically all this interface is saying. So instead of making one building for each user, we're making one extra building. So instead of having one building, we'll have two buildings. But it's better than having one plus the number of user buildings. So we're kind of increasing the efficiency in that way. Is that description okay?
Yeah, that makes total sense.
Okay, thank you.
Yeah, sorry about that. I'm listening.
It's all good. Okay, so security considerations. There's one big one that needs to be considered. It's in the EIP. It's don't use self-destruct. So a lot of people, they would like to have some sort of kill method where you will self-destruct the contract when you're done using it. But with exchanges, you never know when some huge whale will send 500 million ether or whatever to one of your deposit addresses, which is why we want to keep deposit addresses cold if we can. So the problem is that if you self-destruct the deposit contract after you're, like, let's say you shut down the exchange, users who used to use the exchange might still have their deposit address, set into some sort of saved database, or maybe they'll have like some sort of contacts list or something, or they'll have it written on a Post-it note, or I don't know. So what happens a lot of times is we'll switch the wallet of our exchange. Like, let's say we have to update the wallet, and so we have to change all the deposit addresses. And so we tell the users, we say, okay, your deposit address is going to change on this date. Please update any wallets or any contact information or whatever where you have your deposit address saved in. And a lot of users don't do that. So as soon as we switch over to the new wallet, we'll still have users depositing into the old wallet for months and months after we've switched. And even if we stop, detecting those deposits, and we tell the user, if you deposit to the old wallet, we will not credit you. Then what'll happen is they'll send a bunch of money, and then they'll be like, well, why am I not getting credited? And then they'll send us a ticket to our support team, and they'll threaten us with a lawsuit if we don't give it to them, and blah, 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 blah. And it's just a lot easier on us to go in there, manually check and go, okay, they deposited to the old address, we'll credit their account manually. But they still keep doing it. So if you self-destruct the contract, and then you didn't do it in a deterministic way, like using create2, you cannot create the same contract at the same address. So it would be impossible, because the contract address, if you don't use create2, is based upon the nonce of the account that created the contract and the address of that contract. So you would never be able to create the same contract with the same address ever again. So there are ways to get around that. You could use a proxy factory that would basically deploy the deposit contract for you. And that way you would be able to kind of redeploy the same contract again. But it would be a lot less efficient, and it would be very difficult to manage. And one slip up, you would have no way to redeploy the same address or the same contract on that same address. So in general, if you want to kill it, if you want to have some method to kill the contract, you should just have some sort of internal bool element or something like that, where if this is true, then all methods should revert. But if it's not true, then it'll work as normal, and then have some sort of owner mechanism where it's like only the owner can set this to true and kill the contract. So you would need to do something like that, so that it would basically reject any deposits from people who tried to send after the exchange closes down or whatever. That's the only real security consideration that needs to be kind of taken from an exchange deposit perspective. So other than that, it's really just a simple protocol. It's just an interface of the contract and a new address method with a checksum. And so basically, the implementation in a Solidity contract is very simple. I have a proof of concept, which is linked in the EIP itself, but it's so small, it just fits on this slide. So literally, it's just the contract is literally just a deposit method, an internal checksum match method, which we use in the require here to make sure that the checksum matches. And then we emit an event, which is deposit bytes and uint the amount. So that basically we can look at these events on the event log, and then we can use that as our deposit system. Now, obviously, this is not totally secure. You might want to check the constructor address to make sure it's not, the 0 address or anything like that. You might want to add a couple more functions and whatnot, but obviously you want to follow the EIP standard because there's a lot of stipulations, like you can't have a unprotected fallback function that would allow value transactions. So we want to reject all value transactions and require everyone to use this kind of deposit method here. So this is just a very simple implementation. If you have any questions, you can ask them on the GitHub itself as an issue, or contact me on Twitter, or my email is in my GitHub account. You can send me an email, whatever you feel like. Although email is probably less. I'm sure Punja can attribute to my lack of checking email. So email might not be the best way to contact me, but yeah, definitely if you can bring up an issue on the deposit contract POC, I'll definitely look into it.
I just wanted to hop in, sorry,
yeah,
if you don't mind. So I know that the self-destruct method in Ethereum is like a highly debated topic. Yeah. Specifically that people want to remove it. And I'm wondering if it does get removed, would that affect the functionality of your EIP?
No, so it won't affect this EIP at all. There's another method of doing deposits, which you basically create a contract that self-destructs itself in the constructor. So like it literally deploys itself and then kills itself all in the same transaction. And by doing that, because when you do self-destruct, you are refunded the gas of the deployment of that contract. So so basically, you're spending the gas to deploy the contract, and then you're doing some logic like transferring money from the address to wherever, and then you're basically committing seppuku and killing yourself. I don't know of any exchanges that actually use that method, so I don't think many people are affected, but this EIP itself is not affected at all. Okay, so moving on, this is another idea. This is not actually in the EIP, but this is something that I've actually been discussing with other people and considering adding to the EIP, but it's quite a big change and it's kind of iffy. So I'll go ahead and talk about the idea. So basically, you would just keep the address format. So the address format and the 8-byte ID format and how the checksum works and whatnot, that would stay the same. But basically, you would say, OK, we don't even need a deposit contract. What we would say is, if you get an address with this extra 8-byte ID data, what you should do is you should append those 8 bytes to the end of the call data. So what is the call data? The call data is basically whenever you call a contract, you create some data that you add to a place called the call data. So if I'm sending you an ERC20 token, I'm calling the transfer method on that ERC20 contract. So in order to call that method, I have to create what's called a call data, which has the 4-byte method ID. and then the parameter data, which is similar to that kind of get parameters that you were talking about with HTTP requests. So like question mark blah 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 equals blah 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 and blah 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 equals blah blah blah. So in Solidity, which basically translates Solidity language into actual EVM bytecode that lives on the network, there are no checks for when the call data is too long. And there's a lot of reasons for that. And there's a debate going on whether or not there should be checks to make sure that the call data is just the right size. A long time ago, there were no checks on the call data at all. And that was kind of a buffer overflow kind of vulnerability that could happen. But because of that, there were actually like some bugs in some ERC-20 contracts that were not apparent in older versions of Solidity, but in more recent versions, it was apparent. And it actually broke some contracts because what happened was a lot of contracts were relying on the fact that that any contract compiled by Solidity would not actually check to make sure that the call data is a specific length. Right now, if we were to adopt this new idea, we are relying on the fact that the Solidity compiler does not revert when the call data is too long, which is dangerous because there's no guarantee that that will always be true. So that's the big, huge, bad one. If we were to kind of add this to the EIP, we would almost kind of need a verbal confirmation, at least, from the main Solidity devs to be like, you're never going to make it so that a compiled contract will check to make sure that the call data is too long or not, right? You're never going to do that, right? Because if they do that, and then there are some contracts that are, compiled with this new version, then if there was a ERC-20 or something that was kind of created with that new Solidity version, we as an exchange would not be able to deposit to that using this system because it would basically revert. So what you would do is you take the 8 bytes and you just append it to the call data. So if you are sending just a normal value transaction of Ether, then the call data for a normal Ether send is empty. So there's just no call data because you're not calling a contract. You're just sending Ether. But if you're sending Ether, you can actually have any call data you want. It'll increase the gas usage by a little bit, depending on the length of the call data. But you can add call data and it'll just get ignored by the network. So it's kind of like a memo, thing in a way, but it's not supported. It's not designed to do that. So any change that changes that behavior is not technically a hard fork, and anyone that would be using a deposit system based on that assumption would be kind of just SOL if all of a sudden one day Solidity changes in some way or the Ethereum network changes in some way, because a lot of people would just say, well, no one is actually using the fact that we allow call data for value transactions. No one is relying on that, so it's not a backwards incompatible change. And then it turns out that a bunch of exchanges were relying on it, and then it just gets all messy. So the good parts is it's totally backwards compatible with all ERC tokens. So if you sent us, BAT or any token or whatever, all you would have to do is tag on the extra 8 bytes to the end of the transfer method call data, and then Solidity won't even see it. It'll just ignore it. But when we look at that transaction, we can actually pick up the transaction when we see the deposit. And then we can look at the call data, make sure that it's longer than it needs to be, and make sure that it's exactly 8 bytes longer than it needs to be. And then we can take that last 8 bytes and treat it as the ID, and then check the checksum and take the 5 byte nonce and look it up on our table, make sure we know who the user it is that is depositing the ERC tokens. So because it's backwards compatible with ERC-20 tokens, the EIP that I created is only compatible with Ether right now. You could technically create another EIP that would make ERC-20 tokens in the future compatible with this 8 byte ID standard. but you would not be able to do it for any ERC20 token that has already been deployed. But using this method, we would be able to support any ERC20 tokens using this method, as long as they were not compiled in such a way where they send an error if the call data is too long. So it also doesn't require any deployed contracts on the exchange side. So in the building analogy, we don't need to create any extra buildings. We just have one building. And it doesn't increase gas by much. So if you're sending a value transaction in Ether and you're just adding 8 bytes of just random data into the call data, it doesn't increase the gas usage by that much. 21K is the base, and I think it only adds a few gas. So this is the most efficient method, but it relies on a lot of undefined behavior. And we would really need the Ethereum network to kind of come together as a community and say, yeah, this is a lot more efficient, and this will save us a lot of gas. And we want to make this assumption kind of a solid rule so that people can rely on it. And then once we can rely on it, then we can just say, OK, let's have this new address format, and everyone can send to it by adding the 8-byte ID at the end of the call data, and we're done. And now we can support any NFT, we can support any ERC20, blah, blah, blah. And this will basically act as like a memo without a hard fork. Now, if we're going to do that, then obviously it's like, OK, well, we need complete consensus from the community to get this kind of undefined method through. Well, in that case, why not just do a hard fork if we need consensus from everyone? So it's kind of a chicken and egg problem. If we were to add this to the EIP, it increases the hurdle. It increases the barrier of entry for this EIP to be adopted. Similar to the hurdle would be if we proposed a hard fork idea. So that's one of the reasons why this idea wasn't really adopted, or still hasn't been adopted. I'm still kind of trying to figure out if there's a better way to kind of do this. So that is the end of the kind of presentation. So BitBank, bringing value to the world with Bitcoin technology. We were created in 2014, back when Bitcoin was the only horse in town. So yeah, we are, BitBank, and this is the type of stuff we're doing. Any questions?
Sure. So I have one. What is
Okay.
the major difference between a non-hard fork change and a hard fork change?
Okay, so a hard fork change and a non-hard fork change is generally something that affects consensus, and kind of like the way that you can affect consensus is by like changing the rules on how blocks are kind of generated. Now, the reason why adding a memo space would change the rules of the blocks is because currently any miner that has mining software that verifies Ethereum blocks and then mines a new block, they have rules on which how they can parse the block and parse the transactions and understand the transactions. Now, if we add a memo or a destination tag to the transaction, currently there is no space for that. So if we add that space, any program that tries to parse that transaction and subsequently parse any block containing that transaction will basically choke on it. So they will try to parse the transaction using the old rules that they know. And because there's this extra data that they don't understand, they won't just ignore it. And they will just say, OK, this is an invalid transaction, so this block is invalid. Whereas any software that updates with that support, the support of that memo, destination, whatever, they will see it as a valid block. So anytime you have miners on the network or validators on the network seeing the same block as valid and invalid based upon what version of software they're running, that is called a hard fork. So basically, that's why we wouldn't be able to, to add an extra, part to the transaction. Whereas using the call data method, because the current rules of the network and the current rules for parsing says that any transaction can have call data. And that call data is only really looked at if the to address is a contract. So if the to address is not a contract and it's just an EOA account, just a normal public key account, then no contract gets run. So the call data is basically ignored. But because it's the rule of Ethereum that any transaction can have call data, it is not invalid to add call data to a non-contract call. And it's not invalid for most contracts to add call data at the end of the call data that's supposed to be there. But like I said, that could change for the contracts. It could also change for the network if someday, let's say we do a hard fork for proof of stake, and during that hard fork, they decide, oh yeah, if you're not calling a contract and you have call data, we should throw an error. If they decide to do that, then anyone using this new idea that I proposed would be out of luck because it's undefined behavior. So yeah, the major kind of defining point of what is a hard fork on the network would be whether it's a backwards incompatible change on the consensus of validating new blocks.
And so if you were to implement, one of these methods that doesn't require a hard fork, are you basically just implementing a contract that people can use, or are you making actual changes to the base Ethereum EVM?
Yeah, so you are basically just making a contract that people can use. So we're defining the method in which you would use that contract by this interface. And then we're defining the method in which you will tell the wallet, because the wallet is essentially the thing that is actually creating the data that calls into the contract. So the wallet needs to know what that 8-byte ID is in order to call this method. And the way that we tell the wallet software what 8-byte ID to use is by encoding that 8 bytes into the address itself. So basically, we're not doing anything that is a hard fork because we're basically just telling a wallet to use a contract method. And most wallets can do that.
Okay.
Yeah, I have a few questions for you. But before that, I want to mention that I find this proposal interesting. And the topmost reason is, of course, the gas saving part, as you mentioned. But it is also interesting because it is proposed by the chief Bitcoin officer of an exchange dominant on Bitcoin technology. I mean, as your page says, that bringing value to the world with Bitcoin technology. So it was really interesting to know the motivation behind this improvement proposal for Ethereum blockchain. It's fascinating to see how cross-community people are working together to build a decentralized world for blockchain. So my first question to you is about the standard. Like, what is your main argument for having EIP-2876, the one that we are talking today, as the standard, whereas we already have proposals, EIP-681 in the last call that I believe strives to a similar purpose?
Yeah, so 681 URL format for transaction requests. Yeah, so the reason why this is not kind of used is primarily because when I looked at this proposal, this was actually in the pull request where I created the EIP itself. Someone mentioned this proposal. And one of the reasons why I made my separate proposal was because, number one, this is a kind of very complicated scheme that is generalized for all types of contracts. So this kind of scheme would basically, it's very complicated and it's very difficult to implement for different wallets. And from my knowledge, I don't know of any major wallets that support this standard. I mean, there might be some, but I've never really seen any wallets that kind of parse this type of address format, kind of like URL format that is in 681. So basically, I just took the most simple address format that I could think of and basically added in a checksum, which, looking at this, if I remember correctly, there's no checksum here. So it's basically just, or maybe there is a checksum. I remember looking at this when I was told about it when I made the pull request, and there was no checksum. So that also kind of increases what I was talking about before, where users tend to butterfingers their stuff a lot, where like they'll copy some of it and not all of it, or they'll mistype it, or they'll only copy the first 20 letters out of 24 letters or something like that. So having kind of this method where if I accidentally don't copy one of these key values, then it might cause an error or it might do something, whatever. Whereas if we have a very simple address that has a checksum in it, then we can say to the user, this checksum doesn't match, so you're probably miscopying it. So as far as the address format is concerned, I mean, this is very versatile and it's very generalized, so that you can use it to call any contract on any chain, which is very great for many use cases. Whereas the EIP that I created is only for one specific use case, which hopefully will make it easier to adopt.
Makes sense. Getting new proposal is always a good thing. Like it is an addition to new thoughts of, nothing to lose in terms of a standard. So obviously, thank you for the proposal. But as you may know, that implementation must be completed before a proposal can be labeled as a final status.
Mm-hmm.
That brings to my next question on implementation.
Mm-hmm.
I found two separate issues created for implementation in Web3.js and EthereumJS for proposal. And if I understand correctly, for EthereumJS, there is some feasibility issue and it was closed. However, the Web3.js issue was marked stay. So curious to know your thoughts on the possible reason for delaying the implementation. Could it be the bandwidth of priority or complexity of the code? Or maybe, in lack of some tools? Because I believe there were some tools available for other similar proposals, EIP-681 and EIP-381, that is, sorry, not 381, 831, that is URI format for Ethereum. Mm-hmm. What is your general take on the possible reason?
Yeah, so after discussing with Web3 and the other guys at EthereumJS and whatnot, basically their stance was that they do not want to add any code from a specific EIP, and specific EIPs should have their own library. And then wallets who create wallet applications can then call that extra EIP library into their application and then use that separately, so it's not actually in the Web3 ecosystem, whatnot. Now, this is not a difficult thing to implement, and I mean, I have been planning on officially creating a npm package for a while now. But to be quite honest, after going through Ethereum Magicians and going through the different libraries and trying to kind of get it, adopted, I've kind of gotten the feeling and the sense that most people don't really understand the problem statement of this EIP, because 99% of Ethereum developers are not exchanges. They don't work at exchanges. They work on whatever DeFi protocol or whatever, and they get paid in whatever token or ICO or whatever. So they don't really care about the problem, or maybe it would be easier to say they don't have an understanding of the problem. Maybe I didn't explain it well enough, and I'm not championing it well enough. So basically, because I created this EIP to kind of move this issue forward, and then I got a lot of resistance and a lot of indifference where people didn't really care that much. So I thought that the adoption of the standard is going to be a very long process. And so we needed some solutions to kind of decrease gas costs. and also to be able to support different, ERC-20 and things like that. We needed that sooner rather than later. So in addition to this EIP that I've created, I also created a exchange deposit contract, which actually doesn't use this standard, but it actually is based on if this EIP does not get adopted, then what is the cheapest gas cost deposit system that you could possibly create on Ethereum. Can you see the window that I have open?
Yes.
Yeah. So on our Bitbank GitHub, we have a repository called Exchange Deposit Contract. And basically what it does is it deploys a contract per user. But we got it as cheap as possible. So each deploy of the contract is around 60K gas, which for a contract deploy is really, really cheap. The way that we're actually making that very cheap is that we actually have the proxy for the users is written in EVM bytecode directly. And we have that, the bytecode is explained in a huge comment at the bottom. We actually explain how the bytecodes actually work. And by coding it in Ethereum bytecode, we saved a ton of gas. So each user contract is basically 60K gas or so. And this whole contract like system, this system was actually audited by Consensus. So on the Consensus website, you can actually see the public audit of this contract, which this is basically kind of like we're making the best of the worst case scenario. So if the EIP never gets adopted, then we'll just use this contract, which we created, and it's the least amount of gas that we could possibly create. If it starts getting adoption, this contract can actually be modified to support the EIP that I created after the fact by using the implementation address, which was also audited by Consensus. So if you change this implementation address to another contract that supports the deposit EIP, then we would be able to support the deposit EIP after the fact, after we've created and deployed this contract. So we have all of these things, and we're making them open source so that our competitors can use them, and that we can we want more exchanges to use this, because more exchanges using this will lower the amount of gas used by exchanges, which will lower the fees, which will be good for us and good for the network and good for our users. The best thing for gas costs would be having a hard fork that adds memo or destination tag or whatever, and all exchanges start using that for all of their ERC tokens, for all of their Ether tokens, and that will decrease the amount of gas used on the network significantly. The next step would be the EIP that I proposed. If that gets adopted, that will decrease significantly for ETH transfers. For ERC-20, we would need to add another EIP that would modify the ERC-20 interface to have a method that would accept that 8 bytes of ID data. And then basically the worst case scenario would be no one adopts the EIP, and then we can use this exchange deposit contract, which this is kind of like the worst case scenario. And right now we're moving forward with this, but we have it so that we can, after the fact, support my EIP if it starts getting adoption. And we can also support a memo and destination tag system if that ever gets adopted as a hard fork.
This seems, generally speaking, like an expensive endeavor. And so I'm wondering, like, if you don't mind me asking, like, is the reduced gas cost of this functionality like very important for exchanges to be like a viable business opportunity, or like to succeed in the market?
Yeah, well, yes. So one of the large hurdles of creating a new exchange business, a centralized exchange business, obviously, if you wanted to create a new DeFi protocol, all you need to do is do some sort of ICO, and sure, you'll get funding. But with centralized exchanges, The wallets actually cost quite a bit of money, especially if you support like BTC and ETH or ERC20 tokens on ETH mainnet, because just the fees are so expensive. And most exchanges do not charge for deposits. Like if you've ever used a centralized exchange, the only time they ever charge you money is when you send money out of the exchange. Whereas the exchanges actually spend network fees to forward, like I said, in the worst case scenario, if they're forwarding packages from that building, they have to pay the money to create the building. They have to pay the money to forward the package from that building to their main building. So they're paying a lot of stuff that is unrelated to withdrawals, so the sendouts. It would be possible for exchanges to say, like, if you deposit 10 Ether, we will take away 0.4 Ether from what you deposited in order to pay for the deposit.
Mm-hmm.
But none of the other competitors are doing that right now. So who's going to use your exchange if you're basically, nickel and diming every user every time they send in money and send out money? So I'm not going to say exactly how much we spend, but on a monthly basis, I would say easily, like even when there's not a ton of like high fees, like right now it's really high fees because of the DeFi boom and whatnot. But even when the fees weren't that high, I mean, you could easily spend, $10,000 or $50,000, $100,000 if the fees get high enough, just for messing around with the deposits. Like not even talking about the withdrawals. I mean, because we take fees from the users whenever they do a withdrawal, we do make some money back on that. Although recently we're not taking enough. So we're losing money on every Ethereum withdrawal. And then we're also losing even more money on each deposit because we have to, forward that and spend the fees to forward that. And the way that we kind of, make the difference is we're making money on BTC or other smaller altcoins. We're making money on the withdrawals for those. So we're kind of balancing it out. So a lot of our users, they only use one or two coins. So we might have a bunch of users on our platform that only use Bitcoin or only use Ethereum. And so it's difficult because the Ethereum people are really happy right now because we have a set withdrawal fee that is currently more economical than actually sending Ether on a self-custodial wallet, because we can't change that fee so quickly. We can't like change it every day. It's just a set fee that maybe once every couple months we announce that we're going to change it a little bit, but we can't change it every 5 minutes to match with the network. So right now we're losing money on every withdrawal with Ethereum, and we have to make that up by gaining money on the withdrawal fees for other coins. So it's a difficult problem. So I think if we had this EIP, or even better, memo or destination tag added as a hard fork, it would definitely decrease the barrier of entry for people trying to get into the space of accepting deposits from multiple users, whatever that business may be. It might not even be an exchange. In fact, one of my good friends, Nicola Dorier, he's the main guy behind BTC Pay Server, which is a merchant platform. A lot of Ethereans have been like, well, we want you to support Ethereum so that we can use BTC Pay Server because it supports a bunch of altcoins. It supports Dogecoin and all those things. So we want you to support Ethereum, but when, because I know a lot about Ethereum, he asked me about it. And I said, well, the only way to really do that is if you have a bunch of Ether on your merchant server, and every time someone creates an invoice to like buy a product, you don't even know if they're going to pay it, but you already have to deploy a contract to mess around with it. So he was like, yeah, no one's going to use this even if we make it. So if there was a memo/destination tag feature, then you could have these types of merchant applications that are easy to use in a non-custodial manner. So it's not just centralized exchanges. It's in general accepting deposits from multiple people or multiple invoices or multiple shopping carts or whatever. in a way that doesn't waste gas. The current method is wasting gas. So if we can adopt that, I think not only centralized exchanges, but merchant applications, whether it be self-custodial or custodial, will also benefit by having these kind of changes on the network. It is very expensive.
To sort of summarize, I guess, in well, not to simplify too much, but I guess to kind of give like viewers or people who are maybe not too into the Ethereum network sort of an idea of then, because it's kind of interesting to me how you can have this really kind of small, I mean, if they're on one slide, right, this really small change, and then what I'm hearing is that it's going to make the DeFi or the application of Ethereum much more economical, because you don't have to, at least for well, it just makes certain applications possible versus they are not before. And that sort of is important because it means an increased value in Ethereum, I would say, because the infrastructure and the ecosystem grows, and that's ultimately what gives our or gives Ethereum value. So that's a really interesting insight into EIPs in general, I think, but yours specifically. So thank you. I think that's it. I think we're over time, actually. So
yeah,
thank you.
Quick more point, like you mentioned about Fellowship of Ethereum Magician. So I'm moving towards the process section of this series. The first thing that I would like to mention is about the discussion tool link. Like the present EIP that suggests the discussion link is at GitHub repository, I believe, of the author of you.
Yeah.
But recently, the process improvement group, the EIP-2876, have been encouraging to move the discussion link to the Fellowship of Ethereum Magician. That is kind of a standard practice that we are trying to enforce. And obviously, that increased visibility, you will get more community feedback. I see that there is already page created for this proposal. It's just that it's not referring back. I mean, like, it's not mentioned in the EIP.
Yeah.
So was just curious if it is something that can be considered.
Yeah, I mean, I changing the link is not that big of a deal. But to be honest, I've only ever gotten really one issue on the GitHub issue itself, and the thread on the Ethereum Magicians is pretty much dead. So I mean, if it's visibility that's the concern, I think it would it would already be, there would be comments on one or the other if they were seen on either one of them. So definitely down the road, if that's kind of the standard, I would definitely look into changing the link to Ethereum Magicians. But to be quite honest, I mean, right now, I've just kind of prioritized the exchange deposit contract that I just showed you, primarily because after kind of poking around a bit and creating that thread that you mentioned on Ethereum Magicians, and then I also created another thread about adding a tag or memo thing to the blockchain, and not really any responses. Maybe I'm just not good at kind of relaying the issue at hand well enough, or whether that issue is just not really relevant to developers who are working on the next DeFi protocol or whatever. I think that definitely moving this EIP forward will definitely help in the community at large, and I do think that I should champion it eventually and kind of start pushing a little bit more specifically towards different parts of the community. But right now, I just don't really have the time. I've been really busy with work. So, but yeah, definitely, if you or anyone watching this has any ideas on how we can kind of push adoption of this EIP, or maybe push a conversation forward for the next hard fork, because I mean, it's not an and or. I mean, we could have this EIP be supported on all wallets, and then also after the fact create a memo or a destination tag, and then just everyone could switch to that after the fact, and that would be a better. So I mean, I'm just pushing all three of these at the same time and seeing what sticks. We've got the exchange deposit contract, which is MIT licensed. It's audited by consensus. Anyone can use it, adopt it if they want. the EIP, which anyone can adopt it if they want. Hopefully I'll champion it somehow, and maybe we can get more people to kind of support it, more wallets to support it. And then, down the road, if we can convince people that this is something that's good for the network, maybe we could get a hard fork in there. So yeah, I'm definitely cool with moving the link. I'm cool with anything. If anyone wants to create a pull request on any of these repositories or the EEP repository, and they want to help me with this EEP, I could definitely add them as a champion, and they can help me kind of move this issue forward if they feel like it's an issue that they care about.
Yeah, well, I mean, like when you are creating a core proposal, as you mentioned about the hard fork, I am very sure that it is going to get a record attention. But in the meantime, the proposal itself, it is well structured and is already merged as draft. So I think it is good to move forward to the next status of the state at the standardization process. The best status as per the current EIP1 format, it is should be the review, in which can be followed by the last call on your wish, others' wish, when they think that proposal is almost ready and there is no too much of changes required in the spec part. You can go ahead and change to the last call. In last call, generally it is there for 2 weeks. I mean, the minimum requirement is of 2 weeks, but of course, there is no limited duration for the proposal to be in the review section. So if you would like to push it through the standardization process, maybe then it will get some more eyes of EIP editors. So the best thing to do, the first step would be to change it to the review status and then to move it towards the last call.
Okay. All right. Yeah, I'll look into that. Thank you.
Okay. So we are a little over time, but I really appreciate you taking out time and sharing details of this proposal. It was a wonderful presentation, and I hope it gets the attention of wallet or the API providers and be implemented in the major projects soon. On that note, for our YouTube viewers, if you have any further question on this proposal or any other that we recorded earlier, you may leave a comment to us from the author. We are going to provide the Twitter and GitHub handle of the author in the description section, along with the link to the presentation and other resources available for this proposal. Do let us know how you like this episode and which EIP would you like to see in future. Your feedback is important to us, and we'll be able to bring more episodes for you. Do hit like and share. If you are the first-time viewer, don't forget to subscribe. Keep sharing your love with Ethereum cat herders. This is all of us signing out.